Okay, so Radhe Radhe everyone. I think I'm live, okay? Just let me know if you guys can hear me properly or not, okay? So let's do one thing today. It's not yet 9:30 now, okay? So I'll just wait for people to come quickly. Until then, I'll just post it on Discord that I'm live, okay? And then I'll start with the video. I think I will be needing paint. Hmm, okay. I think I'm doing live after a very long time, so it's like I have myself forgotten like what do I check usually. Okay. Okay. So first of all, I'll just put the Discord and that link. Okay, Discord and Instagram link is on the live chat. I've pinned it. You guys can check. Till then, I'll just put it on Discord that I'm live right now, so that people are going to join quickly. Okay. Oh, this paint also I will need in a very smaller thing. I think this is okay, right? So it's like to make it more interactive. It's like it's better that I switch on the screen like this. Okay, it's like a kind of scratch pad or something like that. Okay, so it's better for us to do it because I don't know why I can't pin things. Like earlier, I used to do what I used to pin the live chat over here, but now you can see that if I try pinning it, it doesn't work. Okay, earlier it used to work, but I don't know what happened to that. I was using some hotkeys actually, so that is not working. Okay, so let's start with today's video. Oh, sorry. So yeah, let me read this. So first of all, the first question, okay, it was very simple. Okay, the first question is very simple. Find the closest person. You're given three integers x, y, and z, representing. Just a minute. Huh. The UI has changed, now. The UI has changed a lot. It's good. It's like the previous one was also good. The previous one was better rather. But yeah, this one is also good. I think. X is the position of person 1, Y is the position of person 2, Z is the position of person 3 who does not move. Both person 1 and person 2 move towards person 3 at the same speed. Determine which person reaches person 3 first. So return 1 if person 1 arrives first, return 2 if person 2 arrives first, return 0 if both of them arrive at the same time. So it's basically like this. Think of it like this. I'll use this. Or rather, I'll just put because I am a more fan of black and white. Okay. So let's say here is a number line, okay, and this is where z is there, okay, this is where x is there, and this is where y is there. Now if x wants to come over here, he needs to cover this distance and y needs to cover this distance. So if the distance of y and is between y and z is equal to x and z, then we can return 0, right? Return 0. If between y and z is smaller, so return 2, and if x and z is smaller, so return 1. Now it is like that x and y, x, z, y is like over here, right? Like this. But it is not necessary that y will be over here. Y can be over here also. So in that case, we have to calculate this, right? So to calculate this, we don't know whether y is at the right or z is at the right. So what we can do is we can just use the function of absolute values, okay, and find the distance between them, between y and z, and the distance between x and z. Okay. So basically, if let's say if x is equal to 1, y is equal to 2, and z is equal to 3, the distance between x and z is 3 minus 1, that is 2, and z and y is 3 minus 2, that is 1, right? But if y was at 4, then also the distance would be 1. So in that case, it will be 4 minus 3. Instead of becoming 3 minus 4, it will be 4 minus 3. But what we can do is we can make it 3 minus 4 and make its absolute value count. Okay. So we know that it's going to be that value. Okay. Is it clear? I hope it is clear. Okay. So this is what I am doing over here. You can check the code. So I'm checking if the absolute value of x minus z and absolute value of y minus z, if both of them are equal, that is, if both of them are at the same distance, return 0. If x minus z absolute value is lesser than y minus z, that means x reaches first, so 1. Otherwise, return 2. Okay, so it's basically a one-liner thing. It's very easy, so I just tried doing it in a one-liner. Okay. So any doubt? Because I can't see. Okay, I can't see how many people are watching this. So that's the reason I'm just asking you guys to be quite interactive and do subscribe my channel. Okay, because I can't see you guys.
If you know better way.
And I can see that there are 2 people watching this. So if you guys are watching this, you can like. So what you can do is you can just write in the comment section, live chat, okay. And if you can't write, so I think I have put on the subscribers only mode. So what you can do is you can just subscribe my channel, and this will be, and you can do a quick refresh, and I think you'll be able to write on the live chat, okay. Or what you can do is you can just stop the YouTube, and then you can subscribe my channel, close YouTube, open YouTube, come to my video, come to my live stream, and do it, and it will be working for you. Okay. So let's move on to the next problem. Smallest palindromic rearrangement 1. Okay. You are given a palindromic string S. Okay. And you have to return the lexicographically smallest palindromic permutation of S. So this is one thing, that you're given a palindromic string S. So you can think of it like, what if it was not a palindromic string? Okay. It is not necessary that it will be a palindromic string. So it may be like over here it is given that it's palindromic, but you don't need to consider that, okay, because that is just for your easier understanding. Return the lexicographically smallest palindromic permutation of S. Okay, a string is palindromic if it reads the same. You know what palindromic means, okay, and you have to find the lexicographically smallest palindromic permutation of S. So let's say if you're given us BABAB, okay. Now it may be like it is given as BABAB, which is a palindrome by itself, but you can consider it to be just a normal string instead of it considering to be a palindrome. You can consider it to be a normal string also. Okay, that is what I mean. So let's say if you're having B B B A A. So what is the smallest palindrome that it can give? I mean, when I'm talking about smallest, I mean lexicographically the smallest palindrome that you can get. Okay, from here, it is nothing but A A, and then B B, and then B. You know what? Like in palindromes, it's a better thing that you just fill in all elements from the beginning and the end. Okay, so that it's a palindrome, because a palindrome is a mirror image, right? So the point will be this. So palindrome is a mirror image, right? So AB and AB. Okay, so you have to find it like that. Now, since you have to make it the lexicographically the smallest one, what you can do is you can simply do one thing, that you can simply sort the whole thing out, okay, and then try putting this A. Okay, so let's say if I'm sorting it out, okay, let's say it was not like this. There was a C over here, there was a D over here, there was another D over here, and a C over here. Okay, so this may be a case, right? So what we can do is you can sort it out. So that is A, B, 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 C, C, D, D. Now you just put the values one by one, A and A, right? Then B and B, right? Then B and C. Obviously B and C is not going to work, so go for C and C. Okay, C and C. then D and D. Okay, D and D. And now what we are left with? We are left with B. So now we can press the B over here. So now this is the smallest palindromic substring. Okay, lexicographically smallest palindromic substring. What I meant. Now, now that you have got this, okay. Now that you have got this, so now you know that what is the lexicographically smallest palindromic string and how to find it. Okay, but it's not always a better approach to sort the whole thing. Okay, you can sort it. It's okay because you're given the complexity that you can sort it. The length is 10 to the 5 and n log n is going to be okay with you. Okay, but what if I can make something in big O n? Because we are sorting it just to put it in an alphabetical order, right? But what if I can by default find the alphabetical order? So what I can do is in this whole thing, I can have a frequency array, okay, which is going to have the frequency of all the alphabets from A till Z or Z as you may call it, okay. Now that you have the values of this, all the frequencies of A to Z, now what you can do is for A, how many numbers are there? There are two. So just put it like this: 1, 1. For B, there are three numbers. So I can't put all three of them. I can put any two of them. I put it. For C, 2. For D, 2. For E, nothing. F, nothing. Till Z, there is nothing. Okay, now that you're done with it, now check what frequency did you miss. You missed the B frequency of 3. So put it out. Okay, it will be better if I show you with a better example. So let's say if it was B, 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 right? This is only the smallest lexicographically palindrome. Okay, but what have I told you that how to do it in using frequency? Okay, so frequency will be A will be 0, B will be 5, and remaining everything will be 0. Okay. Now, since at this 5 only we are having the problem, so what we are doing is, first of all, we are subtracting 2 from it. It becomes 3, and then we are putting B and B at the extreme ends. Okay. Then we are again subtracting 2 from it, and we are putting it at the extreme ends. Now, can we subtract 2 from it anymore? No. So we are going to go for the C. Nothing, D, nothing. So you have gone through everything, and now you know that there is nothing that is greater than equal to 2, right? But there is something which is equal to 1 now. So whichever is equal to 1, you can put it in the middle. Okay, so this is what the logic is. I'll just walk you through the code quickly. Vector and frequency of 26, 0, n is equal to s dot length, I is equal to 0, I less than n, and this is a character. Okay, this is for every character. I'm finding its frequency. Okay, and answer, this is going to be, I am initially keeping it as s. You could have gone for like any string of length n. Okay, it would be working perfectly. Then what we are going to do is we are going to traverse from for every element from A to Z. Okay, and if frequency, while frequency of I greater than equal to 2, you just subtract 2 from the frequency, put it at the extreme ends, j and n minus 1 comma j. What is j? J is equal to 0 initially. Okay, and we increment j one by one, so that I'm going to put it at the extreme ends. Okay, whatever the value is coming to be. And now that I am done with all the alphabets from A to Z, now I'm again going to traverse for A to Z, and I find that if any number it is equal to 1, that is, it is greater than 0. In that case, just put the middle element as that element. Okay, that alphabet rather, and then you can return the answer. Okay, so I hope this is clear. I'll move on to the next problem then. Only if it's clear with you guys. I can see there are 2 people watching this, so I think it's good that if you guys can be a little bit of interactive. Okay. Okay, so let's move on to the next problem. Smallest palindromic rearrangement 2. So I won't be explaining what the smallest palindromic rearrangement is. Okay. But over here there is a kind of twist in the tale. Okay. And what the twist is, basically you have to find the kth lexicographically smallest palindromic permutation. Okay. Instead of finding the smallest, you have to find the kth lexicographically smallest. That is, this is it. Okay. You have to find the kth lexicographically smallest. Now the thing is that first of all you have to understand that how can you find this out. Okay, so let's get a little bit into the depth of permutation and combinations. Okay, so first of all you have to understand that what if it may happen that you're given that you have to find out the k is smallest, but it may happen that the k smallest is not existing only. Like they're not k permutations only, right? So first of all, one concept that you need to be very much clear that how to know that how many permutations are possible for the palindrome. Now remember one thing, a palindrome is dependent on the fact that the first half is the mirror image of the next half, right? Think it like this. If this is a palindrome, that means that the first half is a mirror image of the next half. So this next half, it is completely dependent on the first half, right? Now since that it is completely dependent on the first half, so now what we can do is we can just ignore the fact, we can completely ignore the fact that what to say? We can completely ignore the fact that it is like it is we can completely ignore the fact that we have to consider both of them together, right? So what we can do is we can just consider the first part, just this part. Okay, now whatever is the kth smallest permutation that can be made by this part, we can just simply mirror image it into this part, and that will be the kth smallest element. I mean kth smallest kth lexicographically smallest permutation for the palindrome. Okay, so now what our aim is to focus on the blue part. Okay, so we have found the smallest palindrome in the previous expression, in the previous question. If you guys are watching just for this question, I will just tell you that just move on to the previous question and just understand what I have done over there. Okay, so it will be better for you to understand. Now that you know that, now if I put this into half, okay, now if I put this into half, what happens is I have to find the kth smallest permutation of this part. Okay, so now we are going to completely focus on this part. Okay, now how we are going to make the kth smallest permutation is our main goal, right? Well, see, one thing is very you have to understand very clearly. Okay, if you want to find the kth smallest permutation, okay, in a specific part, then there is a trick over there. Okay, what you can do is you can either use the next permutation thing, okay, because there is an inbuilt function of next permutation, and what you can do is you can run a loop from I is equal to 2 till k and make the next permutation one by one. Okay, next permutation, there's an inbuilt function, I think, next permutation in every language, not in every language, but I can assure you there is a inbuilt function of this next permutation in Python and C++. Okay, I'm not sure about Java, but see, according to the condition that has been given, the next permutation takes you big O n. Okay, big O n complexity to understand it. Now see, I know that the s dot length is 10 to the 4, right? Now, if I divide it into two parts, obviously, right? Because I'm dividing the string into two parts. So it will 10 to the 4 by 2, that is 10 cubed into 2. I mean, sorry, 5 into 10 cubed. Okay. And for every specific kth permutation, I'm going to do that. That is 10 to the 6 into 10 to the 3 into 5. That is 5 into 10 to the 9. So what happens? I can show you. I have some submissions over there, but it's like I won't show you the wrong solution. Okay. So first of all, what happens will be like for some cases it will pass, but it will give you at a TLE at a very much edge case. Okay, at a very much, let's say for only 5 or 4, any 5 or 4 test cases won't be passing, somewhat like that. Okay. So in that case, you have to be very much confident about the fact that hmm, okay, so in that case, what you have to do is you have to be very much confident about the fact that whatever you're doing, it's not going to work that way. Okay, you have to find a more optimal solution. Now, how to find a more optimal solution? What you can do is you can find out the fact that there is something related to permutation combination, right? Like we have done such kind of questions in our class 12th or 11th. That is, you're given a number and you can rearrange the digits of it, and we have to find out what is the smallest digit that what is the smallest number that we can have, what is the second smallest number we can have, what is the third smallest number we can have, and so on. Right? Well, let's come. Now let's come to this. Okay. Let's say. Um, First of all, let's just understand. Let's say if there is A B C. Okay. I don't know whether text works or not. It will be better if I could make you understanding in text. Okay, I'll just open the notepad. Okay. I think it will be better for me. Okay. You guys can see the notepad, right? Maybe you guys won't be able to see the live chat. It's okay. See, what happens is that I can do one thing. Put the notepad a little bit smaller. Okay. So let's think it this way that we are having A, B, C. Okay. So what are the permutations it will be having? The first permutation A, B, C. Then it will be A, B, A, C. Then it will be uh, A, B, C, A. Then it will be like this B, A, A, C. I may be wrong. Okay. I may be wrong. But I'll just show you one thing. You have to understand. It's not more about pattern. It is more about mathematics. I can assure you. B, A, A, C. Then B, A, C, A. Then B, C, A. I think this is it. 1, 2, 3, 4. 4 factorial by 2 factorial is 4 into 3, right? No, it is 12. I think I did. I think I missed a lot of things. I can't like find out from here what I have missed out. But yeah, there will be more permutations. There will be more permutations. Now let's say we are going to check for uh, we have to find the third permutation. Okay, let's say this is the third permutation, and I'm going to check whether I have done the right thing or not, whether this is the third permutation or not. So if I want to find the third permutation, what is the count of A? It is 2. Count of B, 1. C, 1. Right? And or let's say if I'm going to find the fifth permutation. Better. Best. Okay. It is, let's say it is A, B. Okay, it will be B, A, C. Right? This is what I have told you, that this is going to be the permutation for that, right? Oh, I think I was right only, because like over now what you can do is you can have this CAAB. So you're going to have 12 ones. Okay. So this is 1, 2, 3, 4, 5. So this is the fifth, right? Now I don't know this permutation table, but I have to find it. Okay. So A is equal to 2, B is equal to 1, C is equal to 1. Clear. Well and good enough. Now, okay, since the things are not that much active over here, I'll just ask you guys. You guys can see me, right? And you guys can hear me and see me, right? Properly. Yeah, the drop frames are 0. So I think I'm streaming at a very good quality today. It's good. It's good to see that. Hmm. Okay. It's okay. It's okay. So let's try to understand it. Okay. So A is equal to 2, B is equal to 1, C is equal to 1. So first of all, I have to check that if I put the first A, the first position, there are 4 positions, right? And how do I find out like how many permutation can this make? It is very simple. Okay. It is factorial of 4 by the factorial of all the frequencies. Okay. Factorial of 2, that is frequency of A, and a factorial of 1, That is frequency of b into factorial of 1 again. Okay. So what will this value be? It will be basically nothing but 4 into 3. That is equal to 12. Okay. So this is 12. So basically we can have 12 permutations from here. Now if at any position we found out that k is greater than 12, okay, in that case what we can do is we can directly say that, oh okay, sorry, we can't do it. We can return a null string. Okay, it was given in the question. You have to return a null string. Okay. Uh, yeah, if there are fewer than k distinct palindrome permutations, return an empty string. Okay, so you can do that. But obviously it is 12 and I am dealing with 5. So yeah, I am well, k is less than 12. Okay, good. So now what we can do is we can fix one position at a time. So there are total 4 positions, right? 1, 2, 3, 4. Now let's fix the first position to be A. Okay, dot dot dot. How many are remaining? A equal to 1, B equal to 1, C equal to 1. Now what is the permutation that we can have? It is nothing but factorial of 3 by the same formula. Okay, factorial of 1 into factorial of 1 into factorial of 1. Okay, what is its value? Its value is going to be 3 into 2, 6. Okay, 6. Great. Now we have to find out whether this k, that was 6, if k is greater than 6, is it so? No, right? So that means that the first element is B. I mean, sorry, the first element is A, and I'm confirmed about it because 6 is greater than 5. So this first thing, I'm confirmed. Okay, so this is it. Done. Now let's go for the second one. Okay, so the second one can be A also, which makes it A is equal to 1, B is equal to 1, C is equal to 1. Sorry, A is equal to 0 now, right? The remaining ones. So now if I do the same thing, obviously it won't be the same value. It will be factorial of 2 of this, right? So what is its value? Its value is 2. Now do the same thing. It was 5, right? So is 2 greater than 5? Nope. Nope. Right? So this won't be the case. But since that this won't be the case, make k minus equal to 2. So what is the value of k now? It is 3. Okay? And this is not the case. So let's go to some other case. Okay. Let's go to some other case. I'll just print it. And let's say the second element is B, because that is the next possible element. Now this happens, right? There is one A and one C remaining. The value of this is same, factorial of 2 by factorial of 1 and factorial of 1. That is 2 only. But the value of k has changed. That is 2 greater than 3. But still 2 is greater than 3. Okay. So now what we do is k minus equal to k minus is equal to, sorry, it is 2. Right? So what does k become? K becomes 1. And which means that B is also not going to be the next element. Okay. So what now we can do is we can go for it again. Okay. And now we make it C. C is equal to 0. Well, this is the same thing. Okay, this doesn't change. But now k has changed. K is this. AACB. Oh yeah, I missed AACB. Right. You're right, you're right. So in that case, the fifth one will be 1, 2, 3, 4, 5. ना BAC होगा. नहीं BACA होगा ना. What am I doing? What am I doing? What am I doing? पता नहीं. So let's try to see it. Okay. So then after that we can find it out. So this is equal to 1, right? I mean, this is k minus won't be walking, right? And k is equal to 1 will be there. Now that since this condition didn't satisfy, I mean this condition since it's satisfied, which means that AC will be there. So now we are going to go with ACA. There are two conditions left: ACA something and ACB something. Okay. So this makes B is equal to 1, and this makes A is equal to 1. Okay. Say so it will be factorial 1 by factorial 1, that is 1 only. Okay. And since this satisfies, the first one only satisfies. Okay. So it is going to be ACAB. Okay. ACAB is the answer. But I am not sure why ACAB. Oh, okay. I think I missed a lot of things. Huh? I missed a lot of things. The fifth one won't be going till B only. Okay. See, first one is this ACB. Then it is ABAC. That's ABCA. ACAB, ना? हाँ. ABCA. उसके बाद ACAB नहीं आएगा. I think ये नहीं होगा. I'm missing something about, or maybe this is it. Okay, so like this is the fifth one. Okay, this is the fifth one, and I just told you how to do the calculations, right? Now that you know the calculations, I'll just quickly go to the code. Okay, because that is the most important thing. Now see, okay, one more thing I forgot to mention. So this factorial things we were doing, right? And we were quite okay with it that yeah, it's working. We are okay with it because we were just considering a very small part. Okay, so factorial of 2 is very small. But what if I'm having a factorial of 10 to the power 6, or rather 10 to the power 3 into 5, right? That is the maximum thing. That is the maximum factorial that we can get. What is the maximum factorial that we can get? It is factorial of 5 into 10 cube. Why is it so? Because it is nothing but 10 to the power 4 by 2. Okay, it's nothing but this. Okay, great. मैंने ये करा था कि मिड तक सबस्ट्रिंग निकाल के नेक्स्ट कॉम्पिटिशन करा, बट और शोन के लिए हाँ ये दिखाएगा, मैंने भी किया है. Even I did it. Okay, because I just told you. Okay, I just mentioned that why it will be giving you this thing, because it is 5 into 10 cubed. Okay, so for this next permute, this function is going to go for 5 into 10 to the power 3, and you have to do it for k times, right? And the value of k is 10 to the power 6, the maximum value of k. Now if I multiply both of them, it becomes nothing but this. Okay, and this is very much evident ki haan, this will give you a TLE, right? So okay, let's try to understand what we are doing. Okay, now since you know that this is okay, now you can see that it is going to give you a TLE, or it, like, okay, this is going to give you a TLE, whatever he mentioned, Priyank, and whatever I am telling you, that this factorial thing, even this will give you a, like, memory limit out of, or integer overflow, right? Because it is not possible to have such a big factorial, right? It is never possible. But you know what? Like the digits, the number of digits, you can have it in the factorial, right? Instead of having the factorial, you can find out what are the number of digits in the factorial, right? How to find it out? Just use log 10, right? And log 10 is so absolute and so minute that it will give you the opportunity to store a very big number in a proper order. That is factorial of 2 log n. So let's say factorial of 1 and factorial of 2. Both are having one digit. Both are one digit numbers. Okay. Even factorial of 0 is a one digit number. So if you're just going to check for the digits, it's not possible, right? To just check for the digits. So if I'm just doing the log base 10 of it, so I am storing the number of digits in it as well as the proper value of it. Okay. And since you know that if I'm going to make this whole thing as log, okay, let's say I was going to make this whole thing as log. You know what this will be? It will be nothing but log of, okay, so log of, let's say 306, okay, 6 by 1 into 1 into 1. Okay, this is what it is. That is log of 6, right? That is RHS and LHS going to be same. Okay, but what have I told you? You like this is equal to log 6. I know that, but now let's tell you this is going to be log 6 minus log 1 minus log 1 minus log 1. This is what the logarithmic thing means. But let's say this is well and good that it is 6, but this is actually not 6, this is actually 3 into 2, right? So it will be log of 3 plus log of 2 minus log of 1, log of 1, log of 1. And if you look at it, it will be log of 6. So if I am using the log, if I am using the log value, it is better for me to store it, right? And now I'm going to show you the code because we have done it only. We have done that only. So just first of all try to understand what I have done. Okay, n is equal to s dot length. So this is basically nothing but the previous thing only, just a little bit more optimized version. Okay, so what I'm doing is if n is equal to 1, return k is equal to 1. Like if k is equal to 1 and n is equal to 1, so it is going to be s only. Otherwise it's going to be nothing. Okay, because like if n is equal to 1, this is a edge case that I was going stuck with. Okay, so that's the reason I just coded it directly. There was a thing called, there was a O, okay, and you have to find out the first smallest thing. Okay, but what I was doing was like, since you know like logarithmic is very much minute, so I was getting an empty string for this, which is not the case, right? Empty string is not the case for this. It will be O only. I was getting the empty string because it is the middle element, one thing, and logarithmic of 1 is equal to 1. I mean, sorry, logarithmic of 1 is equal to 0, right? So these things it was getting a little bit hampy crampy, okay. You know, log of 0 and log of 1, that's thing also. So that's the reason I had to do this, okay. I had to do this. I had to put this condition separately, okay. So that's the reason I'm doing it separately. In the previous one also, I just counted the frequency of all the characters. Then I'm going to divide the string into two parts, the first and the half. Okay, I'm going to make it half half. Okay, and whatever I get, okay, from the first part, I'm just going to put it into that thing. And this is just what I have done earlier. Okay, till now this is what I have done earlier. Now the kth half. Okay, because you know that I am going to find the kth permutation for first half, right? So if kth half dot empty return this null, this is one of the things that I have done. But what over here we are doing is we are getting the kth permutation for the half and k. What is half? This is the first half. Okay, this is the first half of the smallest permutation. Or you can even not consider the smallest permutation because it doesn't matter anymore, right? Whether it is smallest or not, because you're not focusing on the what is the smallest. You're focusing on what is the kth smallest. So whatever I get from here, I'm going to reverse that half. Okay, so I'm getting the kth half. Okay, now that I have reversed it, now what I can do is I can just put the kth half and the reversed half, and this middle is only if, let's say, if there is some condition that the length of the whole string is odd. Okay, so in that case the middle element I'm not going to consider throughout only, right? In no computation I have to consider, because that will be in the middle no matter what, right? So that is it. So this part, very simple, as I have explained earlier. Okay. Now we are going to go to the main part of the question, that is getting the kth permutation. Okay. So let's. I don't think control works here, right? No. It only works in VS Code and IntelliJ and Eclipse. Okay. So see, what happens is I'm going to get the kth permutation. The same thing. Okay. S dot length is equal to 1 k. This thing. I just told you what. Now what I'm going to do is I'm going to find the frequency of all the alphabets over here. And I'm going to compute the log factorials of s dot length. Okay, sorry, of s dot length. And then if I find that if the count permutation of frequency comma s dot length is lesser than k, return zero, return nothing, because you know that it is a possibility that if it is lesser than k, then you can say that sorry, it's not possible. We are not going to do it. Okay, but if it's not so, then only we are going to do it, right? So now what we are going to do is string of result, and in remaining is equal to s dot length. So this is basically nothing but this is simpler. Okay, this is simpler. So first of all, let me show you how I'm going to compute the log factorial. It is very simple. I just go on making it factorial of I. This is a recursive thing, you know. Factorial of I is equal to factorial of I minus 1 into factorial of I. I mean into I. But since I'm going for log factorial, so I'm going to get it in the base of log 10. Okay. And what is count permutation? Count permutation is nothing but whatever I was explaining in the previous part. Okay. So let's say if I'm having the frequency of array and I'm having the remaining. Okay, so what I was doing, I was just checking for the remaining, that is this dot dot dot, right? So this is the remaining thing, and I'm having the frequency. So what you can do is you can find the factorial. What was thing for it? It was factorial of factorial of everything that is remaining, okay, divided by factorial of the frequencies, right? So this is only what we are doing. We are going to find the factorial of remaining, and then for every frequency we can have the log denominator. Okay, obviously we are having the log denominator. So what we can do is f greater than 1 and log denom plus is equal to this, because overall whatever we are going to get, we are going to subtract it. Okay. So what I'm going to simplify it. Okay. So I was doing it like this, right? This is what I'm basically doing. Okay. I'm computing this in the denom, and then I'm subtracting the whole thing, the whole denom from it. Okay. Log num minus log denom. And if log result this, then return long max. This is a reason why, like let's say it is exceeding 18 digits. Okay, so you can see it from here, 18.06. This is some calculation, I don't remember. I think it was 9, 10, 11, 12, 13, 14, 15, somewhat like 14, 12, something like that. Okay, so that this is the first position where this is 18. Okay, that is if it exceeds 9. If it exceeds the 9 digits, and I'm putting it as a thing of greater than that, so we can directly return long max, because this is just to overcome overflow of integer. Okay, or rather int. Obviously int is going to give you a overflow, or rather let's say it's long, right? Of long. Okay, after that what we can do is you can cast it back to power of 10 comma result plus 10 to the 6. Okay, this is because k was equal to 10 to the 6. So what it happens is, like, we can have a better modulo of it. Okay, so I think it is okay for you guys to understand what I have done till now. And yeah, remaining is equal to s dot length k minus minus, and if while remaining is greater than 0, so what we are going to do is we are going to check for all the alphabet in a one order and find out whatever the if frequency of I is equal to 0, then continue, because like this is what I was talking about. Since over here you found that this frequency is 0, so we are not going to consider the A only, right? We just considered B and C. So that is what I am doing. So long count is equal to count permutation frequency comma remaining minus 1. That is whatever is remaining minus 1. Because let's say over here 3 was remaining, right? So what we did, 3 minus 1, right? That is 2. So for all the checkings, we were going for 2, right? 3 minus 1. And we're just putting all the numbers in an alphabetical order. That is A, B, and then we tried with C. Okay, so this is it. If you're finding any problem in understanding, you guys can write in the live chat. Okay. So if k is less than count, result plus is equal to a plus I. This is basically nothing but the alphabet corresponding to ith value. Okay, and then you can say that remaining minus minus. So like if it is k less than count, so it means that yeah, we are okay with it. We can go to the next what's that next position. Okay, this position is fixed. This is going to be this element is going to be in this position only. This is fixed. Go to the next one. This is fixed. Go to the next one. This is fixed. Go to the next one. Normally that. Okay, and then we can return the result. Okay, so I hope this is clear. Any confusion? Write in the live chat.
Guess what? 3 hours. In just 3 hours, I learned how to use ChatGPT and AI. 3 hours. Just 3 hours.
Okay, so I think we are okay to go with it. Let's go to the last problem. The last problem, the solution, it is completely a chat GPT generated. So it's basically nothing but it will be, I'll just explain you the logic of it, okay? Because I was I was very less on time, so I just explained chat GPT that this is the idea that I'm going to do. You just code it for me, okay? And chat GPT coded it for me. Okay, so I think we are okay to erase everything over here, or rather, let's keep it over here in case if anyone comes with some doubt. Okay. Okay. So what the last problem is all about? Let me first explain it. Count numbers with non-decreasing digits. You're given two integers L, R represented as strings and an integer B. Return the count of integers in the inclusive range L, R whose digits are in non-decreasing order. When represented in base, okay, when represented in base P. Okay, so it basically tells us that you have to find out all the numbers in L, R which, if represented in base of B, the digits are increasing order. Or it was decreasing order. No, it's increasing order. Non-decreasing order means increasing order. Okay, but it is obviously not a strictly increasing order. So yeah, we are okay to go. So one thing, whenever you're given this L, R, and it was given that the value of L, R is very big. Okay, L, R is 10 to the power 100. The value it can become. It can go from 1 till 10 to the power 100. Okay, so this is not a perfect thing for us to compute it properly, right? So what we can do is we can find out the digits be increasing order. Let's say this is, we are going to store it into DP. So if I want to find out for 0 to R, okay, whatever this is going to give me, and if I can find out from 0 to L minus 1, whatever it is going to give me, then I can find out from L to R how much it will give me, okay, by subtracting both of them, right? Now this L minus 1, so remember one thing, I can't compute L minus 1 also, right? Very easily, it's not possible to do it. So what we can do is, we can just simply have a other operation for it, okay? We have to compute it in a different operation, in a string manner, okay? So I hope this is okay with you guys, till DP I think this is okay. Now see, what we can do is, we can just convert this everything. We can convert everything, this L and R, I mean not everything, obviously this L and R, into base B. Okay, convert L and R into base of B. Okay, now that I've converted L and R into base of B, so let's say L is of some digits and R is of some digits. Okay. Now if L and R is of same digits, then it's okay. But if it is of different digits, then it's a problem for us, right? So what we can do is, since we were doing the calculation of DP, okay, earlier, so we are going to have a DP calculation over here also. It is very, very much complex for you to understand this, what I have done over here, okay. So what we can do is we can convert it into B. So let's say if, let's take some, let's say if I'm working with base of 8, okay, octal system. Okay, and then I'm converting the L into its octal value, that is 27, and R into its octal value is nothing but uh, 32. Okay, so what is going to be the value for this? It is going to be 27 only, right? Not 28 and 29, because they don't come into the octal value only, right? So since that so first of all, remember one thing, initially you have to convert everything into the base of B. Okay, convert everything into base of B, because now my base has changed, it's not 10. Okay, so first of all, convert everything into base of B, then check what is the condition that we have to satisfy for this, because like if I would have given you that it is base of 10, it will be easy for you using permutation combination, right? You can find out like for every 5-digit numbers what is the what how many are there. So let's say if I'm going for 5-digit numbers, what I can do is in the first position, okay, what I can do is in the first position I can put any of the 9-digit numbers. Okay, in the next position I can also put 8-digit numbers. No, it depends on the digits that you're putting over here. So if I'm putting 1, 2, 3, 4, 5, 6, 7, 8, 9, right? These are the 9-digit numbers that you're going to put, right? Well, now based on these numbers, the next numbers will be there. Okay, so if it is 1, there can be 9 digits again. If it is 2, there can be 8 digits. 3, 7 digits. 6 digits. So I hope this is clear. You're getting it, right? So what is it? It is going to be for 2-digit numbers. We can just go for 9 into, for every specific 9 of them. You can go for 9 plus 8 plus 7 plus 6 plus that. Okay. So if we want to find out all the 2-digit numbers that satisfy this condition, how can we make it out? It is going to be nothing but 9 plus 8 plus 7 plus dot dot dot. Right? Now if you are going for a better position, okay. So now that we know how many 2 digits are satisfying, based on that we can find out how many 3 digits are satisfying. How? Because the 2 digits are fixed now. Okay. Now we are going to choose the third digit for every specific one of them. So this is basically a thing. Okay, this is basically the calculation that you have to find out. Okay, I think it's better that I don't make you guys understand this problem, because this was a kind of like a too higher version of permutation combination. Okay, so I think it's better that we move on to the ratings of today's contest. Okay, a part that I wait for a lot. ठीक है, चलो फर्स्ट प्रॉब्लम वेरी इजी भाई, फर्स्ट प्रॉब्लम वेरी इजी था। ठीक है, सेकंड प्रॉब्लम क्या था, आई फॉरगॉट। और स्मॉलेस्ट पैलिंड्रोमिक 2, smallest count number with non-decreasing. Okay. Chalo, I think the second problem was easy. It was not medium. It was like if you know the things, it will be. I think I will be giving it as a medium hard. Okay, C. And D was hard. D was hard, undoubtedly. Okay. So this is the rating of today's contest, guys. Any doubt, anyone? Otherwise, I'll just end the live stream. I'm live streaming after a long time. So yeah, I'll just end it. Anyone, bhai, do it still shows me two watching, okay. And I know that there's someone who is watching it from the beginning to the end. So whoever is watching it, you guys can write in the live chat, okay. And anyways, thank you, guys. Thank you, bro, for watching it from the beginning to the end. Okay. And it is not me because yeah, my YouTube is closed. And anyways, like two watching it can't be me also. Even if it was one watching, then it would be me. But two watching, one is me and the other one is someone else. Okay. So I think we are okay with it. So let's end the live chat. Okay. So bye guys, and I think I will be coming live at uh, for the code forces thing. I don't know. What did I say? Did I ask you any question? Which one? Which one prison? Okay, prison. If you have any doubt, you can just do one thing. You can just ping me up on Instagram or Discord. Okay. This is the link. This is the pin link. Even if I end the live chat, it will be there on the comment section. Okay. It is lagging. I don't think it's lagging. I think today it was a very good quality of stream because I can see that there is the drop frame is zero, completely zero. Okay, the chat thing. Yeah, chat thing. It may be lagging a little. Put link several times. You have put link several times. I didn't get it. क्या लिखा उसने? अरे यार shit. Okay, just a minute. My YouTube chat got moved. I'll just reply you. Job offers. Job offers. Okay, it is not showing the link. Achha, achha, achha. USACO Training Gateway Chapter 1 last section. USACO. Oh, convex hull trick. USACO Training Gateway Chapter 1. This one. Friday the 13th. Section 1.2 ना हाँ यही तो आ रहा है. This one ना Friday the 13th. Is Friday the 13th really an unusual event? This is, does the 13th of the month land on a Friday less often than on any other? This one, broken necklace, etc. Broken necklace. हाँ हाँ ठीक है रहा मिल जाएगा broken necklace here. Here are two examples. N is equal to 29. Figure 1, figure B. R is equal to red B. The beat considered first and second. A may be represented as string of B and R, the beat represented B and R. Okay, suppose you have to break the necklace at some point, lay it out straight, collect beads of the same color from one end until you reach of the different color. The same for the other end, which might not be of the same color. Determine the point where the necklace should be broken so that the most number of beads can be collected. You have to break the necklace at some point, lay it out straight, and then collect beads of the same color from one end until you reach the bead of a different color, and do the same for the other end. So it's now okay, you got it. Okay, great. Remember the necklace should be broken so the most number of beads can be collected. Okay. I think this is more of a circular thing, no? This is more of a circular thing. So I think this will be uh, this is 5, 3. Uh, the solution for this should be 5, I guess. No, it's 11. Yeah. Let the constraints in the original website tell Big O and Square can also work. Yeah, I'll just check it. I'll just check it. Just a minute. Huh? Consider two copies of the beach kind of okay to run around to necklace bead or okay. So white is a different kind of bead only. Okay, I was thinking that white is the same bead. So bead. Okay. So white is a different bead. So obviously you can choose this of it as a whole. Okay. You can make it R R R R B, B. While can be I didn't notice that. I didn't notice the white thing. I just noticed it right now. Okay, so it is like assignments B 5 plus 6, right? Okay. Eight bits can be collected without breaking the point. Okay, so this is also the answer is also given now. Great. I think this is I don't get it. Like why B comes over here, or maybe it is not the place where the B should be broken. It is about RR the thing. Okay. 5XR, yeah, at 1, 2, 3, 4, 5, and 1, 2, 3, 4, 5, 6, 6XB. Yeah, 5XR, 5, 6XB. So it's basically like you have to find R and B's only. Okay, so what you can do is you can concatenate both of them. Okay, you can concatenate both of them, and then you can find out how many R's you can get or how many B's you can get based on the first thing that you're encountering. So over here, if I want to, the first thing that I encounter is B, right? So I can put all of them as B and this as R. So 3 plus 1, 2, 3, 4, 5. That is 5. 5 plus 3, that's 5, 6, 7, 8. 8, right? Not gonna work. Now go to the next R or W. That is this. Okay. So R, W, R, and then B. Not gonna work. Next B, B, R. Not gonna work. Next R, R, B. Not gonna work. Next R. So you can go on like that. Okay. B, R, B, R, B, R alternatively. Okay. And you can find out whatever is going to be the best option for you. And yeah, you can go to W also. Okay. And remember one thing that at one go you can't go till what do you say? You can't go till a specific number. So what you can do is you can have a DP out there. Okay, I'm not following your questions. Like it is blue, there is a different color. White can be either color red or blue. Yeah, I'll just explain you. Okay, what I mean. So let's say let's take this example only. Okay, right? What he's doing is he's basically doing nothing but he's concatenating the whole thing. Because obviously, if you're having the beads like this, okay, okay, I'm just pointing over here. We're having the beads like this. So after this bid, it is in a circular manner. Okay, so it comes back to that only. So you can consider this to be a thing also. Okay, this is also a thing. I sorry, I mean this. Okay, because it can be like either you're considering these beads or this ones. It's up to you. Okay, right? So the best approach is to there are two approaches. Okay, you can do. There are two approaches that you can do. One approach is just for every specific element. So let's say if you're at W, so what you can do is you can go to the next. Okay, you can jump to the next nth element. Okay, I 2 n plus 1. Yeah, yeah, right. So you can jump to the next nth element. Okay, so this is a B. Okay, so now what you can do is you can find out for this B. Okay, so there are some W's. So W's can be ignored. Okay, so this is one of the conditions that you can do, but I think that is what he has done over here. But I won't be a big supporter of that condition. I will be a big supporter of this condition that first of all you go for, so since it is a W, so first of all you find out whichever is at the minimum distance. So what you can do is you can have a DP out there, and this DP can traverse from right to left. Okay, right to left to find the first place where it is red or blue. Okay, towards right. Okay, so you can do that. So from whenever you are at W, so what you can do is if you are at W, you can find out whichever is the smallest, B or R. Okay, B or R. Based on that, you can do the traversal. So if you find that, so from this W, B is the smallest, okay? So B is nearer, R is farther. So what you can do is you can convert all these W's into B, and then you get another B, and the moment you get a R, now the W's will be converted into R. Okay, so R. So this is a valid thing. Okay, this is a valid thing, and you have to notice one thing, that the length of this can't exceed n. Okay, so what is its length? 1, 2, 3, 4, 5, 6, 7, 8. 8. Okay, good. Now that you are done with B and R, now what you can do is you can go to the next R. Okay, you can go to the next R, and you find out this RWR, BR, B. Okay, so this is one of the things that you can do. That is what I prefer doing, is because, like, if you're going to consider for all the W's, it is not going to give you the optimal answer, right? Because you have considered for this, means that you have considered for this also, you have considered for you consider for this also, you consider for this also, you consider for this also. Okay, so you can ignore all the B's right away. Okay, so this is one of the logic that I have come up with. But yeah, if you want to go for the logic that he has done, so what you can do is, let's say if you are at this position BR, so this is a valid condition. So what you can do is you can check for BR, right? So obviously if you're starting from B, so you have to only consider B, and if you're starting from R, you have to consider that. Okay, so this is not a basic thing, so it's better that if you're given the opportunity to go for big O n squared, and somewhat, it's not big O n squared, I told you, right? It is big O 2 into n to be very much appropriate. You're not going for big O n squared because you're pre-computing everything. So yeah, you can do it in big O into n. Okay, okay, so yeah, so that's it. So I'll just end my screen. Okay, okay, bye, bye, brother, bye.